Power quality has become an important issue because of the increasing sensitivity of electronic equipment and the high costs resulting from the loss of supply. Furthermore, structural changes in power generation result in a higher susceptibility of the power systems to malfunction. Therefore, the use of power quality analyzing devices is becoming more and more common. New regulations like the standard IEC 62586 are appearing to guide the testing and calibration of devices used to measure power quality. The Power Quality Signal Generator Test Module enables the generation of signals for simulating power quality phenomena with a CMC test set. It provides the entire functionality required to test power quality meters according to the new standard IEC 62586. To test a power quality meter, the CMC 256 Plus is the first choice because of its high accuracy. You can also use other CMC products like CMC 356 or CMC 353 if the accuracy requirements allow it. For example, to test Class S power quality meters. The PQ Signal Generator Test Module allows the definition of tests which consist of a sequence of individual test states. Each test state represents the output of a defined signal for a specified time to simulate a specific power quality phenomenon. The assessment of the meter's reaction to the applied signal can be done either manually or automatically. The results of the test are logged in the test report. In this tutorial, we will show you an example of a type test with the Power Quality Signal Generator module as it is done by the manufacturer or a certifying body. Doing so, we will perform one of the power frequency tests according to IEC 62586-2. The nominal frequency of the power quality meter under test is 50 Hz, while the nominal line-to-line voltage is 100 volts. The first step in the power frequency test is to check that the averaging interval is 10 seconds. That is, the frequency readings must be obtained every 10 seconds. According to the standard, we have to vary the frequency in a ramp as shown in the picture. The ramp lasts 10 seconds. Its highest value is 57.5 Hz, and the lowest 42.5 Hz. Keep in mind that these values are only correct for a 50 Hz power quality meter. According to the test criteria of the standard, the value measured every 10 seconds shall stay the same within twice the intrinsic uncertainty of the meter. Furthermore, the total number of frequency readings must be 11, 12, or 13 in 2 minutes. We will use a new OCC file to perform this test. The information in the test object must be completed prior to the test. For the power frequency test, we enter a nominal frequency of 57.5 Hz. The reason for choosing this value will be explained later in this video. The nominal primary line-to-line voltage is 110 kV, while the secondary voltage is 100 volts. The current ratio is 600 amps to 1 amp. The global hardware configuration allows you to define the inputs and outputs of the CMC that need to be used. We require 3 voltages and 3 currents to perform this test. Remember to perform a wiring check before proceeding with the test. Now we insert the Power Quality Signal Generator Test Module to conduct the power frequency test. The test view allows you to specify the states used for the test. At the beginning, there is only one test state by default. Go to the States tab to insert a new state according to your needs. The signal type can be chosen from the drop-down menu. These signal types are set in accordance to IEC 61000. You can also use the Quick Insert button and change the signal type in the test view. All test states can be renamed accordingly. Since IEC 62586 specifies that the power frequency test must last 2 minutes, we can execute the ramp 12 times to match the specification. This can be done by entering the right value into the number of loops field. The detail view contains the specific parameter settings of the test state that is selected in the test view. Accordingly, the content of the detail view depends on the signal type of the selected test state. Use the Help menu to learn more about the detail view configuration of a specific signal type. The upper area of the detail view holds the specification of the incident times and the voltage or current channels that the signal is applied to. In order to set the incident times, it is necessary to take a few facts into account. Since we want the ramp to start immediately and to be repeated afterwards, the pre-incident and post-incident times can be set to 0 in this case. For the power frequency test, one can see that the incident time will be on the tip of the triangle. Therefore, we can assign the shortest time possible, which is 1 millisecond. The nominal voltage is linked to the value specified in the test object. The reason for entering a frequency of 57.5 Hz in the test object becomes clear at this point. The upper limit of our ramp is set to this value by default. Use the checkboxes to select which voltage channels you want to apply the signal to. A box that is unchecked does not imply that the output is deactivated. It only means that the nominal voltage will be output at this channel. Remember that any output can be deactivated from the hardware configuration. The lower part of the detail view contains additional settings of the ramp. The incident value is the minimum value reached by the ramp. In our case, it is 42.5 Hz. The purple background of the voltage indicates that the value is linked to the nominal value specified in the Rio block. Each ramp takes 5 seconds, which makes a total of 10 seconds for the 2 ramps. The threshold value is the value where the power quality meter should detect the incident. Since we do not want the meter to detect an incident, but to check the averaging interval, the threshold value is not required. Therefore, it can be set to any point below the incident value. Anyway, the threshold value is only a graphical representation, and it will not influence the test. In the General tab at the Detail view, you can choose a binary input for the automatic assessment of the test. Just check the binary input box and select the signal from the drop-down menu. Remember that the signals must be enabled in the hardware configuration. This option requires a meter that provides you with binary outputs for the assessment. In this example, we will proceed with a manual assessment so that no binary inputs are required. You can also define the state of the post-incident binary outputs. They can be set to open or closed during the post-incident time of the state. Furthermore, you can define the magnitude and phase of the current outputs. For the manual assessment of the test, it is necessary to insert an assessment state. The 2 test states are grouped together by default, which means that both states will be repeated according to the number of loops specified in the entry field. Since only one assessment is required, you can use the Split button at the States tab to segregate the assessment from the power frequency test. Likewise, you can use the Merge button to group the selected test states. As the assessment state is meant for manual assessments, you can include an instruction for the tester in the detail view. For instance, we can define an instruction according to the requirements and specifications of the standard. If you want to repeat all tests, you can enter the number of repetitions in the overall loops entry field. A wait state can also be used to apply nominal values during the test sequence and to pause the test sequence. You can define a maximum wait time or continue the test manually. Starting the test causes the test progress window to open. This window provides you with detailed information about the test sequence, estimated time for each state, states count, and current state information. With the Highlight Current State box, you can see the current state in the test view. By reading out the values from the power quality meter, we can assess the test according to the specified instruction. In this example, we have checked a total of 12 readings. You can enter any result in the comment field. Since the frequency of all measurements is within the intrinsic uncertainty, we can assess the test as passed. Now we have finished the very first test of the power frequency tests according to IEC 62586-2. To save time for preparing such tests, Omicron provides you with a number of templates for testing power quality devices according to the standard requirements. These templates are accessible from the Test Universe start page and are stored as OCC files on your hard disk. Instead of building your own OCC file from scratch, we will show you how to use these templates. The available templates have been designed for power quality meters that operate with nominal values of 60 Hz and 120 volts. A meter with different nominal voltage or frequency requires an adjustment of the corresponding values. We can take the template for the power frequency as an example. The different modules in the OCC template include a pause module to describe the tests that will be conducted. Prior to the adaptation of the template, save it with a new name in the folder of your choice. Doing so, you make sure that the original template will not be modified. We start off by entering the voltage and frequency settings for this example, that is 50 Hz and 100 volts. The capabilities of the power quality signal generator test module are many. For instance, you can test the variations due to single influence quantities. This test is specified in Section 1.3 of the standard. With this test, you can check the influence of the voltage and of the harmonics on the measurement uncertainty. The local hardware configuration must be checked before the module is configured. The multi-incident signal type is used to generate any combination of the signals available, which turns out to be a perfect solution for this test. This signal type can combine power, frequency, flicker, voltage unbalance, harmonics, and interharmonics. Each of these signal types can be individually parameterized according to your needs. In the first multi-incident test state, the signal types power frequency and voltage unbalanced are combined. Since the template has been created for 60 Hz, it is necessary to adapt the related values. The incident value of the frequency must be changed according to the standard. The voltage must be set to 10% of the declared input voltage. In our case, this is 10 volts. In the second multi-incident test state, the influence of the harmonics are tested. Therefore, the signal types power frequency and harmonics are combined. The frequency incident value must be adapted as in the previous case. The harmonics do not require any adjustment since they are relative values that refer to the nominal voltage of the fundamental. Remember that this voltage was set in the test object.